Number 7, we're told that this system of equations has infinitely many solutions. We want to describe the solution set in terms of some arbitrary parameter t. So what we do is just use our process for solving a system of equations. I'll use this first equation to get rid of the 3x and the 4x by multiplying by an appropriate number. So I will just start here and say I'm going to convert this system by taking minus 3 times equation 1 and adding that to equation 2, and that's going to become my new equation 2. So that's going to, minus 3 times equation 1 looks like this. That's a positive 3z equals negative 15. And so I'm going to leave equation 1 alone. And when I add this, the 3x and the minus 3x will cancel out. That's the whole point of doing that. Minus 3y and a positive y is minus 2y. And then a plus 3z and a plus 3z is 6z. Negative 15 plus 11 is negative 4. Then I'm also going to just clear out that last equation, that x, out of that one by taking negative 4 times equation 1, adding that to equation 3, and that's going to become my new equation 3. So underneath here I'll write down what that looks like. So this is negative 4 times equation 1. It's negative 4x minus 4y plus 4z equals negative 20. And so if I add that to equation 3, you're going to get 0x, negative 4y and positive y is negative 3y, 4z and 5z is 9z, and negative 20 plus 14 is 6, negative 6. Okay. So now I can adjust these equations by, I can get a 1 here very easily by just dividing through by negative 2. So I'll do that first, then I'm going to end up multiplying it by something. So I can do it all at once, but let me just make it look easier by taking negative 1/2 times equation 2, and that'll leave this top equation alone. And this equation becomes positive y minus 3z, and I want to put them a little farther over just in their appropriate columns here. So positive y minus 3z equals positive 2, as long as I don't mess up signs. Well, actually I can do the same thing here. Let's just multiply that one by negative 1/3 times equation 3. So we'll take care of both of those at once. And the same thing happens. Notice I get positive y, and multiplying that by negative 1/3 of minus 3z equals positive 2. So those two being the same, all I will do is take negative equation 2 and add that to equation 3, making that my new equation 3. So my system turns into x plus y minus z equal 5. The second one I'm going to leave alone is y minus 3z equal 2, but that last equation is going to get wiped out completely, so it's gone. And that 0 equals 0 tells me I have infinitely many solutions. And so what I do is I'm just going to let z equal t, the parameter t, and then from this second last equation I'll have that y equals, not equals, but I mean you can do it as equals, but let me plug it in. I'll have y minus 3 times z, but z is t, equals 2. Therefore, y equals 3t plus 2. So there's my y, here's my z. Now I'll take both of those and plug into this top equation, first equation, and I'll have x plus y, but here's y, 3t plus 2, minus z, but z is t, and that's supposed to equal 5. So that's going to give me x plus 3t plus 2 minus t equal 5. So I can see over here I've got 3t minus t, that's going to be 2t, but I'm going to bring it to the other side. So that's going to be x equal, when I bring it over there's going to be a minus 2t, and then this 2 is going to come over as a negative 2, so I believe I'll have a positive 3. So if I did everything right, it's a positive 3. I did everything right. There's my x, y, and z, and we write that as an ordered triple. Minus 2t plus 3, 3t plus 2, and t, where t is any real number. And you can check real quick to see if it worked by plugging in 0. That's an easy one. When I plug in 0, I get the point 3, 2, and 0. Let's see if that works in all three of these. 3 plus 2 minus 0, that worked. Gives me 5. 9 plus 2 is 11 plus 0, that worked. And then we've got 12 plus 2 is 14 plus 0. Now, that doesn't guarantee all of them are going to work, but picking one randomly like that and it working is probably a good chance that they'll all work. So there's my general solution to this to this system of equations.